Welcome back to the class on a numerical part 6. In this lecture, we are going to discuss about some numericals which are depending upon the starting methods of a induction motor. In the first question, a three-phase full load squirrel cage induction motor has a maximum torque equal to twice the rated full load torque. The ratio of motor starting torque to the full load torque, if it is started by the direct online starter, star delta starter, auto transformer started with a 70% of the tapping. The per phase rotor resistance and per phase standstill reactance referred to the stator are 0.2 ohms and 2 ohms respectively. Neglect the stator impedance. Slip at which the maximum torque occurs Sm equal to R2 by X2 equal to 0.2 by 2 equal to 0.1. We know the relation between the starting torque to the maximum torque, that is equal to Sm by 1 plus Sm square. Substitute all the values, we are getting the 2 by 10.1. So from this expression, we can find out the starting torque equal to 0.396 full load torque. Relation between the starting torque to the full load torque in a direct online starter. Suppose if you want to start the same squirrel cage induction motor by means of star delta starter, with the star delta starter, the starting torque is 1/3 of the DOL starter. So the starting torque equal to 1 by 3 times the, this is the torque developed in a DOL starter. If you simplify this one, you are getting the 0.132 full load torque. The same manner, with auto transformer starter, the starting torque equal to 0.70 whole square, because in the numerical it is given that 70% of tapping. So the torque is directly proportional to the square of the voltage. So 0.70 square into 0.396 T full load, we are getting the 0.194 T full load. Now we come to the second numerical. A 10 kilowatt 400 volt 3-phase induction motor has a full load efficiency of 0.87 and a power factor of 0.85. At a standstill and rated voltage, the motor draws a 5 times the full load current, develops a starting torque of 1.5 times its full load torque. An auto transformer is installed to reduce the starting torque and to give the full load torque at a starting. Neglect the excitation current of auto transformer. Then determine at a time of starting the voltage applied to the motor terminal. The torque developed in induction motor, that is equal to, that is given as a numerical T starting, that we have taken as a 1 equal to 1.5 times the T full load, that is directly proportional to the voltage scale. So here we have taken the voltage 400 volts, that is given in numerical, the same value we have taken here scale. With a transformer, the starting torque equal to full load torque, that is proportional to V1 scale. But in case of auto transformer, we apply the less amount of voltage. That's why here we have taken the V1 scale. We want to find out this value. So T starting in first case by T starting in the second case with auto transformer. We take the ratio between these two. Then we are getting this expression. We are getting the V1 equal to 326.6 volts. Next, current drawn by the motor. For 400 volts motor, draws a starting current of 5 full load. This is given in numerical. For a 326.6 volts, the motor starting current is directly proportional to the voltage. So 5 IF by 400 into 326.6, we are getting the 4.0825 I full load. Now the motor full load current IFL equal to, this is the power rating divided by the root 3 VL cos pi. Substitute all the value, that is a 19.52. So the motor current equal to 4.08 into 19.52. We are getting the 79.6904 amperes. Because the motor starting current, it is given the relation. This is the full load current taken by the motor, but the starting current is more than the full load current. This much of current will be taken by the